everyone, in this video we'll discuss about the concept of dynamic memory allocation. Dynamic memory allocation is manual allocation and freeing of memory according to your programming needs. As you know, an array is a collection of a fixed number of values. Once the size of an array is declared, you cannot change it. Sometimes the size of the array you declare may be insufficient. To solve this issue, you can allocate memory manually during runtime. This is known as dynamic memory allocation in C programming. As can be seen, the length of the array is 9. But what if there is a requirement to change this length? For example, if there is a situation where only 5 elements are needed to be entered in this array, in this case the remaining 4 indices are just wasting memory in this array. So there is a requirement to lessen the length of the array from 9 to 5. Take another situation. In this case there is an array of 9 elements with all 9 indices filled. But if there is a need to enter 3 more elements in this array, now in this case 3 indices more are required. So the length of array needs to be changed from 9 to 12. This procedure is referred as a dynamic memory allocation. The dynamic memory allocation can be defined as a procedure in which the size of an array is changed during the runtime. To allocate memory dynamically, library functions are malloc, calloc, realloc, free are used, and these functions are defined in the header file #include std lib.h. First one is the malloc function. Malloc stands for memory allocation. The malloc function reserves a block of memory of the specified number of bytes, and it returns a pointer of void which can be casted into pointers of any form. It reserves memory space of specified size and returns the null pointer pointing to the memory allocation. The syntax is ptr is equal to class type star operator, then malloc function, then byte size. In this case, ptr is a pointer of class type. The malloc function returns a pointer to the allocated memory of byte size. For example, ptr is equal to int star malloc 50. When this statement is successfully executed, a memory space of 50 bytes is reserved, and the address of first byte of the reserved space is assigned to the ptr pointer of type int. Let's see another example. ptr is equal to float star operator, then malloc function, and 100 into size of float. This statement allocates 400 bytes of memory. It is because the size of float is 4 bytes. 100 into 4, 400. And the pointer ptr holds the address of the first byte in the allocated memory. The expression results in a null pointer if the memory cannot be allocated. Let's see another example. Inside the main function, declare a pointer of integer type, and ptr is equal to malloc 15 into size of star ptr. A block of 15 integer is allocated. If ptr not equal to null, If this condition is true, then star ptr plus 5 is equal to 480. 480 is assigned to the sixth integer because the pointer ptr holds the address of the first byte in the allocated memory. Plus 5, that means sixth integer. Next one is the clock function. The name clock stands for continuous allocation. The malloc function allocate memory and leave the memory uninitialized, whereas the clock function allocate memory and initialize all bits to 0. This function is used to allocate multiple blocks of memory. It is a dynamic memory allocation function which is used to allocate the memory to the complex data structure like array and structure. And each block allocated by clock function is of same size. The syntax is ptr is equal to cast type star operator then clock function n comma size. This statement is used to allocate n memory blocks of the same size. After the memory space is allocated, then all the bytes are initialized to 0. The pointer which is currently at the first byte of the allocated memory space is returned. For example, ptr is equal to float star then clock function 25 size of float. This statement allocate contiguous space in memory for 25 elements of type float. Let's see the example of clock function. This code calculates the sum of an arithmetic sequence. Inside the main function, we have declared a pointer ptr. This pointer will hold the base address of the block created. I is a variable for loop and some variable initialized with 0. Then after that, ptr is equal to clock 10 comma size of int. This statement allocate contiguous space in memory for 10 elements of type integer. If ptr is equal to null, error, memory not allocated. The allocation may fail if the memory is not sufficient. In this case, it return a null pointer. Then after that, will printf function display the message, building and calculating the sequence sum of first 10 terms. Then for loop I is equal to 0, I is less than 10, plus I. And inside the body of for loop, star ptr plus I is equal to I. And sum plus is equal to star ptr plus I. Compute the sum of all the integers. When this condition becomes false, control transfer to the out of this for loop. Then with the help of printf function, display the value of sum. And then free ptr. The free function is called to release deallocate memory in C. By freeing memory in your program, you make more available for use later. Next is the realloc function. Using the realloc function, you can add more memory size to already allocated memory. It expands the current block while leaving the original content as it is. Realloc stands for reallocation of memory. It can also be used to reduce the size of the previously allocated memory. If the dynamically allocated memory is insufficient or more than required, you can change the size of previously allocated memory using the realloc function. The syntax for realloc function is ptr is equal to realloc ptr comma new size. This statement allocates a new memory space with the specified size in the variable new size. And after executing the function, the pointer will be returned to the first byte of the memory block. The new size can be larger or smaller than the previous memory. We cannot be sure that if the newly allocated block will point to the same location as that of the previous memory block. This function will copy all the previous data in a new region. It makes sure that data will remain safe. Let's see the example for realloc function. Inside the main function, ptr is a pointer of character type, then ptr is equal to char star malloc 10. Now the size of char is 1 byte and this statement will allocate 10 bytes of memory. Then strcpy function. strcpy function copy the string programming in ptr. Then after that, with the help of printf function, display the string and address of ptr. And after that, ptr is reallocated with the new size. Then strcat function concatenate in C with string programming. Then with printf function, display the string and address of ptr. Then after that, call the free function. Next is the free function. The memory for variable is automatically deallocated at compile time. In dynamic memory allocation, you have to deallocate memory explicitly. The free function is called to release or deallocate memory. By freeing memory in your program, you make more available for use later. The memory allocated using functions malloc and calloc is not deallocated on their own. Then the free function is used whenever the dynamic memory allocation takes place. It helps to reduce wastage of memory by freeing it. Let's see the code for free function. Inside the main function, we have declared one pointer ptr of integer type. When this statement is successfully executed, a memory space of 10 bytes is reserved. The address of the first byte of reserved space is assigned to the pointer ptr of type integer. If ptr not equal to null, if this condition is true, then star ptr plus 2 is equal to 50. Value of the second integer is 50. Then after that, call the free function for memory deallocation. And what will be the output of this code? Value of second integer is 50. As we know that the address of the first byte of reserved space is assigned to the pointer ptr of type integer. This is all about dynamic memory allocation in C.